Alright, standard 12, very simply solving trig equations. If you're good with all your trig values, this is actually really easy. Okay, so if you've done your time test, any kind of understanding solving equations in general, this is pretty straightforward. Okay, I'll do a few examples with you. Most of them I'm just going to ask you to solve for all x values on the interval 0 to 2 pi. Solve for all x values on the interval from 0 to 2 pi. Because really, there are an infinite number of solutions to all of these. Okay? I'm not going to make you list all of them, I'm just going to make you list all the solutions between 0 and 2 pi. So let's try this first one out for instance. 3 tangent squared x minus 1 equals 0. Anytime I see a trig equation where there's only one term that has a trig function in it, I'm just going to try and get that by itself. Okay? So I'm going to add one, oh, let me change that real quick. I'm going to change that to the square root of 3. Okay? I'm going to add 1 to the other side. Or no, I'm not. Sorry, it's a Monday. So 3 tangent squared x equals 1.
Wait, so you're getting rid of
I'm getting rid of the square root, yep. My brain's not working quite yet. I'm going to divide by 3. And then to get rid of the squared, I'm going to square root both sides. Okay? So I have the tangent of x equals plus or minus the square root of 1/3. Okay? What is the square root of 1/3 simplified to? What's the square root of 1? 1. What's the square root of 3? Square root of 3. So you have 1 over the square root of 3, but 1 over the square root of 3 is actually root 3 over 3. Okay? So I have the tangent of x equals a positive or negative root 3 over 3. Okay? This value should look familiar. Those are some of your answers on your time test, right? When is the tangent equal to a positive or a negative root 3 over 3?
30 degrees or pi over 6.
30 degree reference angle, right? Okay? 30 degrees. The tangent of 30 is root 3 over 3. How about in the second quadrant? That'd be negative root 3 over 3. That would work too, right? Okay? So in this one, I want all x values between 0 to 2 pi such that if I plug them into this equation, it would either equal a positive root 3 over 3 or a negative root 3 over 3. Okay? This one has 4 answers. Pi over 6, which is like 30 degrees. Second quadrant would be 5 pi over 6. Third quadrant, 7 pi over 6. And fourth quadrant, 11 pi over 6. Every single one of those answers would satisfy this equation. Okay? Obviously you can keep going around the circle more and more and more, but I only want answers between 0 and 2 pi. Okay? Questions on that first one? Any question you have might be a good one. Okay, let's go to the next one. Again, I only see one trig function. You guys tell me, what should we do?
Subtract 1.
Subtract 1.
Divide by 2.
Divide by 2. The sine of some angle equals a negative 1/2. It's going to be a 30 degree reference angle, but in what quadrants? Where is sine negative? 3 and 4. So I'm looking for the angles down in quadrants 3 and 4 that have 30 degree reference angles. 7 pi over 6 and 11 pi over 6. If you're not good with your radians yet, think of what the answers would be in degrees. That would be 210 degrees, 330 degrees, and then just change them to radians by multiplying by pi over 180. That will take you a lot longer, alright? But it'll work. Okay, get your answer in degrees, change them to radians. I'm going to keep going pretty quick here. 2 sine x cosine x plus root 3 sine x equals 0. Once you start seeing multiple terms with multiple trig functions, I would see if I could factor this at all. I would see if there's anything the first term and the second term have in common that I could pull out as the greatest common factor. Okay, what do both terms have in common? Sine x. So I'm going to take the sine x out. What would be left in my parentheses? 2 cosine x plus root 3 equals 0. Okay, I just factored out a sine x. Why would I do that? Well, because I have it set equal to 0, if I have something times something equals 0, what can I do with each of those somethings? Set them equal to 0, because if something times something equals 0, either the first something has to equal 0, or the next something has to equal 0. Is this something that's pretty easily to solve? Is this something that's pretty easy to solve? That's what you do. You solve them both. Okay? When is the sine of x equal to 0? 0 and pi, right? X equals 0, x equals pi. How am I going to solve this? Subtract root 3. Divide by 2. When is the cosine of one angle would equal a negative root 3 over 2? 30s again, right? And in which quadrants is cosine negative? Second and third. So think of your 30-degree angles in the second and the third quadrant. 5 pi over 6 and 7 pi over 6. Here's a couple answers that would work. Here's a couple answers that would work. By all means, we're solving equations, so if on a test you want to make sure you have the right answers, what should you do with these answers? Plug them back into the beginning, make sure they satisfy the equation. Questions on anything so far, or this one specifically? Speak up. Again, any questions you have might be very good questions. Monday morning, right? If you think of a question, don't be shy, okay?
Could you solve it without factoring?
I don't know how you would solve that one without factoring. Yeah, I mean guessing and checking, but you could guess and check all day long. That would take a very, very long time. Yeah.
Okay.
So that's one type of factoring, pulling out the greatest common factor. There's going to be another type of factoring. It's called quadratic factoring, basically. Carson, can you throw me that eraser, please? Thank you. Let's ignore the cosines for just a moment and follow along. I have something squared minus just one of those things, minus 2 equals 0. X squared minus 1x minus 2 equals 0. Can everybody agree that this is the same as this, but instead of cosine x, I'm just using x?
Yeah.
Okay? These are just quadratic equations. When you were taught how to solve quadratic equations, I guess the way I would always teach it is I hope to God you can factor it, because if you can't factor it, you got to use that silly quadratic formula that's really long and complicated, and you always get unnice answers. Okay? So I hope I can factor this, which the ones I'm going to give you are factorable. I will not make you use the quadratic formula with sine, cosine, and tangent. That would be brutal. Okay? Alright? So when you look to factor, you first look to see, is there anything in common I can take out of all three terms? And in this case, there is nothing that all three terms have in common. So then I just automatically go straight to this, and I think what times what gives me x squared, x times x, and then I think what times what multiplies to -2 but adds to -1.
Two, positive, -2 and.
A -2 and a +1.
Yep.
Would you guys agree that if I would FOIL this back out, it would equal what I have right here? So then how is that going to look then if I use cosines?
Just put cosines in front of
Cosine x minus 2, cosine x plus 1. Okay, instead of x, it's going to be cosine. So it'll look just like this. Cosine x,
-2.
minus 2 and plus 1. So now I have a factor times a factor equals 0. So what am I going to do with both factors?
Set them equal to 0.
Set them equal to 0. Add 2. When does the cosine of x equal 2?
Never.
Never, because what's the biggest value cosine ever reaches? Think of the graph. 1. There's nothing there. Okay? Subtract 1, cosine of x equals -1. When does the cosine of x equal -1?
270, so
Over here.
3 pi over 2.
That's sine, I believe. Right? Because sine's your y
Is that
value.
pi?
Oh yeah.
Pi is the only one. Okay? Pi would be the only answer to this equation. Questions?
On the left side.
What's that?
What about on the left side right after?
When does the cosine of x ever equal 2? It doesn't. Can't. Nothing would, there is nothing that would satisfy this equation ever. Okay? Think of your cosine graph, how it only goes up to 1 and down to -1 and up to 1 and down to -1. Never reaches 2. 1's the biggest value, -1's the smallest value that the cosine of some angle will ever equal.
The video stopped.
What's that?
No, it's still going. It just has the thing popped up.
Low battery. I'll try to finish up. Thank you. One more here. When we put a coefficient in front of the x squared term, factoring becomes a little bit more difficult. Okay? Some of you probably used a little special factoring trick maybe.
I don't know.
I'm getting weird looks, so alright. The things I'm going to ask you to factor are not going to be overly difficult. I think guessing and checking is a perfectly good way to do the factoring that I'm going to ask you to do. Okay? You got to do a little bit of mental foiling in your head or mental distributing, but I don't think it's overly difficult. So I see 3 terms. Is there anything all 3 terms have in common that I can pull something out? No. Okay? There is no greatest common factor, so I'm going to go straight to this. What do this term and this term have to multiply to make?
2.
2 sine squared x. What's the only way that's possible?
1 sine squared x and 2 sine.
One of them's going to be just regular sine x, and the other one's going to be 2 sine x. Okay, so 2 sine x times 1 sine x is going to equal your 2 sine squared x. Now, the last 2 values in these binomials have to multiply to how much? They got to multiply to -1. So guess what your options are? A +1 and a -1, or a -1 and a +1. The trick doesn't work. You can't think what multiplies to -1 and adds to +1. First of all, there isn't anything, but the trick doesn't work, okay? Or that method doesn't work because there's a value in front of, there's an a value in front of your x squared term, okay? There's a coefficient in front of the squared term. So really, I just guess and check. I'm going to go ahead and guess wrong, okay? So I'm going to do a quick little mental foil. 2 sine times sine gives me my 2 sine squared, right? Then I have -2 sine x plus 1 sine x. What does -2 sine x plus 1 sine x equal?
Negative sine x.
negative sine x. I don't want negative sine x. I want positive sine x. So that means all I got to do is what?
Change it.
Change the signs. Okay? Now let's do a little FOIL. 2 sine squared, got that. Plus 2 sine x minus 1 sine x, got that. Minus 1, got that. So now I know my factoring is correct. Yeah.
I know, like, doing factoring problems like that, but not having, like, sine, cosine, or tangent, what do you do if there is a number in front of the first pairing or whatever? You multiply it by the last third.
Yeah, that special factoring
Yeah.
trick or method where you take the A value times the C value, then you write down all the things that multiply to that, but looking for the ones that add to the B value.
Does that not work?
No, it works just fine. I just think it takes too long. That's me. Works just fine, because it's still a quadratic, okay?
Yeah.
It will definitely work every single time.
How would you encode it that way? How would you?
Well, 2 is your A value, 1 is your B value, negative 1 is your C value. Do it just like you would if you were doing 2x squared plus 1x minus 1.
Okay.
Yep.
I didn't know if you had to do it,
Nope.
do
There's,
the sign in there.
nope. Just remember when you go to finish the problem, don't make this an x. Just make sure you make it a sine x.
Okay.
All right? Now what do you do with both factors?
Set it equal to 0.
Set them equal to 0. Add 1, divide by 2. Subtract 1. Got a lot of 30-degree reference angles today. Sorry about that. Okay. Sine x equals 1/2. When does sine x equal 1/2?
Pi over 6 and 5
Pi over 6 and 5 pi over 6. When does sine x equal negative 1?
3 pi over 2.
There's your 3 pi over 2, you bet.